Okay, so let's take a look at solving rational equations. So when we're going to solve the equation, so we simplified before, now we're solving, so we're finding out what x is. So first, you're going to have to factor all denominators. Oops, I don't know why it starts with step 5. That should be step 1. Then you're going to determine the least common denominator, so that's going to be step 2. Then you're going to multiply every term by the least common denominator so that they can all be the same in the denominator. That way, when the denominators are the same, they actually can cancel out and go away. So now you're just going to solve, and then you do have to check for extraneous solutions which live in your denominators because the denominator cannot equal 0. So here, check denominator. And if it does equal 0, then you have to throw that solution out. So if we take a look at this example here, what I mean by check for extraneous solutions, we should know right away that x, because the denominator is made up of x plus 4 and x plus 4, that means x cannot be negative 4, because if x ends up being negative 4, when you plug negative 4 in, you get 0 in the denominator, and you cannot have 0 in the denominator. Negative 4 plus 4 is 0. Again, you can't have 0 in the denominator. That's undefined. So first we looked at that. Okay, factor all denominators, done. Determine the least common denominator. So here the least common denominator is going to be just an x plus 4. Now you're going to multiply every term by the LCD if it needs it. So this first term already has a x plus 4 denominator. This term already has an x plus 4 denominator. This term does not, so I would be multiplying it by x plus 4 over x plus 4, which means I would get on the top 2x plus 1. Oops, I'm going to write a different color. I would get 2x plus 1 plus 3 times x plus 4 equals negative 2. And because all of the denominators are x plus 4, you can go ahead and cancel them out. And we're just solving a linear equation. So if all the denominators are the same, then you can go ahead and cancel them out. So I'm going to write that on the side as kind of like a little note for you. When solving, so you can only do this when solving, when there's an equal sign. If all denominators are the same, then the denominator can kind of just be ignored or cancels out. That's not true when you're simplifying. That's just when you're solving. So when you have an equal sign, a left and a right side, that means. Okay, so here, this should be Algebra 1 solving. We've got 2x plus 1 plus 3x plus 12 equals negative 2. Combine my like terms here. I'm going to get a 5x plus 13 equals negative 2. Subtract 13, 5x equals negative 15. Divide by 5, x is negative 3. Check with my extraneous solution I wrote up here. X can't be negative 4. So this answer is good. X equals negative 3 does in fact work. Okay. Take a look at the next one. Again, it's nicely already factored for us. So we're going to figure out what can x not be. X cannot be, if you look at the denominators, 1 or negative 2. Whatever would make it 0. So x minus 1, if you set that equal to 0, you'd get a 1. X plus 2 cannot equal 0, you'd get a negative 2. So x cannot be those, and I have to make sure that I go back and check that. This time the LCD is a little bit longer, but not bad. The LCD is made up of x minus 1 times x plus 2, that whole thing. So that first fraction here is missing an x plus 2, so we're going to multiply by x plus 2 over x plus 2. The next one is missing an x minus 1 over an x minus 1. And the next one has everything, so we're good to cancel out the denominator and just focus on the numerator. So 3 times x plus 2 is equal to 4 times x minus 1 is equal to 1. Oops, I did not equal. Plus, too many equal signs. And then again, it's just an algebra 1 problem. 3x plus 6 equals 4x minus 4. Combine my like terms on the right side. So I'm going to get a minus 3. I'm going to subtract 3x over. That's going to get me an x. And then I am going to add 3 over, and x is going to give me a 9 here. Wonderful. Again, I'm checking with my 1 and negative 2 at the top. It is not one of those values, so it does work. I will show you what happens when it doesn't. We will get to that. Okay, let's take a look at the next one, number 3. So again, I'm kind of looking at that denominator to see what can x be. X cannot be 3 or negative 4. So this one gives you the 3, this one gives you the negative 4. Can't have those solutions. Okay, what is my LCD? My LCD is made up of x minus 3 times x plus 4. And you can really just look at the LCD also to decide what x cannot be. So a couple ways to kind of look there. So in the first fraction, we are missing a x plus 4. So I'm going to go ahead and multiply by x plus 4 over x plus 4. The second fraction, I'm missing an x minus 3. So I've got an x minus 3 and an x minus 3. The third fraction, I'm missing an x plus 4 and an x plus 4. So now that the denominators are all the same, they're all x minus 3 times x plus 4, I can focus on just this numerator here. So just this part. So when I do that, I'm going to have 2x times x plus 4. And then I'm going to have x plus 1 times x minus 3, and it's going to equal x minus 1 times x plus 4. So this is going to be doing some work here because we've got distributing here. That's pretty easy work. But we've got a FOIL here and a FOIL here. So you've got some algebra coming your way. So we're distributing. That gives me a 2x squared plus 8x. Here I'm going to FOIL. X times x is x squared minus 3x plus x minus 3. Other side again, I'm going to FOIL. X times x is x squared. Then I get a 4x, then a minus x, and then a minus 4. So we got a long expression here. I'm going to combine my like terms on the left. So I've got a 2x squared plus x squared. That's a 3x squared. I've got a 8x minus 3x plus x. That's going to go ahead and that's going to get me a 6x. And then I've got the minus 3. On the right side, I can just combine the middle. 4x minus x is going to give me a positive 3x. Notice this is a quadratic. You've got an x squared, which means it needs to be equal to 0. So I've got to move everything over. Again, I like to keep the x squared positive. So I'm going to subtract x squared. And then I'm going to subtract 3x and I'm going to add 4 so that the right side has absolutely nothing on it. So that's going to get me 2x squared plus 3x plus 1 is equal to 0. Now, you're trying to solve. The easiest way to solve one of these is to factor. If you can't factor, you'd have to use something like the quadratic formula, but this is factorable. So we're going to go ahead and see what multiplies to 2 and adds to 3. 2 times 1. So I'm going to split the middle into a 2x and a 1x. The first two have a GCF of a 2x. The second two have a GCF of a 1. So I'm going to get 2x, x plus 1. Here I pull out the 1, leaves me with an x plus 1, which leaves me with, oops, I said 2x, but I forgot my x. Leaves me with 2x plus 1 times x plus 1 equals 0. And if I solve each of those, I subtract 1 and divide by 2, I get a negative 1/2. The other factor, I subtract 1, gives me a negative 1. And then I check back at the top, x can't be 3 or negative 4, which it's not. So both of these solutions work. So look at that. That's a lot more algebra work right there. So you got to be careful with your math there. All right, let's take a look at number 4. Notice number 4, they're not all factored. So now we do have to go ahead and factor this. To make it less work and less writing for me, I typically just like to kind of cross it out and write the factored form. So remember, this one here, we're seeing what multiplies to 4 and adds to -5, which would be -4 and -1. So when I factor this, I'm just going to cross this off and write x minus 4 times x minus 1. So now I can go ahead and see what is my values of x that it cannot be. It can't be 4, and it can't be 1. So I got that from looking at the denominators, 4 and 1. So I'm going to have to check my answer with that. Okay, so my LCD then is obviously going to be made up from that. It's the x minus 4 times the x minus 1. So the first fraction is good. It has the denominator. The second fraction does not. I need to multiply by x minus 1 over x minus 1, so we have a common denominator. The third fraction, it's missing an x minus 4 times an x minus 4. So now my denominators can cancel out because they are all the same, and I'm solving an equation. So I'm solving the equation x plus 11 equals 5 times x minus 1 minus 3 times x minus 4. Notice that we're distributing a negative there, so you got to watch out. So x plus 11 equals 5x minus 5. Here again, I'm distributing this negative 3x plus 12. I'm going to combine my like terms on the right side. 5x minus 3x is 2x. Negative 5 plus 12 is a positive 7. I'm going to subtract x, which leaves me 2x minus x is x. I'm going to subtract 7, which leaves me with x is 4. Well, notice x cannot be 4 because it would make the denominator 0. So I'm going to throw this answer out, and my answer for the whole thing is no solution. So you can either write no solution or a 0 with a slash in it. That would work, okay? All right, there's one last problem on the back, and typically I have my students do this problem themselves to kind of see if they know what they're doing. So I would pause me and go ahead and try it. But if not, I'm going to go ahead and do it with you if you need the extra help. So again, you need to factor this. This is a difference of squares, so it's 2x minus 3 times 2x plus 3, which means my LCD is going to be 2x minus 3 times 2x plus 3. And that also means x cannot equal, if you add 3 and divide by 2, positive 3/2, or subtract 3 and divide by 2, negative 3/2. So x cannot equal those two things. Okay. So if I take a look, my first fraction here is missing a 2x plus 3, so I'm going to go ahead and multiply that here. My second fraction is good. My third fraction is missing a 2x minus 3. So again, what I'm doing here is I'm going to go ahead and solve the top part because now that the bottoms are all the same, they cancel out. So I'm going to have 3x times 2x plus 3 minus, and it's minus this whole thing, so you've got to be very careful here. It's actually minus 12x. If you're going to write plus 9, then you have to have that parentheses in there because you're going to have to distribute it, or you can change it right away to negative 12x minus 9, up to you. And then x times 2x minus 3. So we've got some distribution for all of these. So 3x times 2x is 6x squared. 3 times 3x is 9x. Minus 12x minus 9. Here we're going to go ahead and distribute. X times 2x is 2x squared minus 3x. I'm going to combine my like terms here. 9x minus 12x is negative 3x. Now I'm going to move everything over because it's a quadratic, so I need it equal to 0. But I want to keep the x squared a positive number, so that's why I subtracted 2x squared, and I'm going to add 3x. 6x squared minus 2x squared is 4x squared. Here, negative 3x plus 3x is actually gone. And then we have a minus 9 equals 0. So you could either use the square root method, you could add 9, divide by 4, and square root both sides to get plus minus 3/2, or you could factor this, which is 2x minus 3 times 2x plus 3, which gives you two solutions, x equals 3/2, and x equals negative 3/2, which we know is part of our solutions that it cannot be. Sometimes only one solution is thrown out, but sometimes you can have two solutions thrown out. Both of these do not work, so your answer again here is no solution. Hopefully you got that as well.